Let's continue on now with problem number dos. Graph the function, again, using transformations on the coordinate plane. And so pretty much almost the same steps, just now a different type of function. So we have to label these 5 points and graph this guy. Okay, so this is an absolute value function. And the absolute value function is the v. And the first thing that we always do is we always want to plot that vertex first. And my vertex is, again, like if I come over here, if I have a times x minus h, or the opposite value of x minus h minus plus k, then my vertex will be hk. So in this case, I have x plus 0 or x minus 0, so that's kind of like my h. So my first term will be 0, but then my k will be -6. So that's where my vertex is going to be, using this whole guy right here. So go down to -6, and that's going to be my vertex. Okay, I'm going to use the shortcut again, and the shortcut is over 1 up 1a, over 2 up 2a, over 3 up 3a. Okay, and again, this is my value of a right here. Okay, this is my value of a. So let's think about this. Over 1 up 1 times a. Well, a is 2, so I'm going to go up 2. Okay, so there's a point there, and there's a point there. Oops, that guy needs to actually go over just a tad. Let me do that over again there. All right, so down 6 right here. Okay, so 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. Okay, so let's go over 1 up 2. Over 1 up 2, right? Okay, so now we're going to go over 2 up 2a. And a again is 2, so I'm going to go up 4. 2, 4. Okay? And 2, 4. So it's going to be symmetrical. I can stop there because it only says 5 points, but I just want to go until I hit the x-axis so I can have my next intercepts. Over 3 up 3 times a. And since a is 2, it's going to be 6. So 2, 4, 6. Nice. It's going to cross nicely right there and nicely right there. Since these are straight, I'm going to use my cool little cheat little thing right here. Watch this. I could be like, whoa, oh, you tricked me, Mr. Check that out. Heck yeah. I love technology, but not as much as you see. All right. Enough of that. That's from Napoleon Dynamite, by the way. Should have won an Oscar, but I'm not sure what happened there. All right, so we labeled our 5 points. Let's actually now label them. We plotted them, but let's actually label them. So that's 0, -6. That would be 1, -4. And this would be 2, -2. And now I'll go to this side. Now, it doesn't matter. I just said 5. As long as you label 5, you're good to go. Okay. And notice, again, they have arrows at the end here. Okay, that's very important there. Arrows mean they go on forever. -1. -4, -2, -2. By the way, that's a -4 right there, by the way. And that's 5 points. Okay. What's the vertex? Again, we already know it's down here. So that's 0, -6. The x-intercepts, easy, right? 3 and -3. So those are the x-intercepts. Wata and wata. Okay, so that's good to go right there. So we have 3. Let me get that out of there, though. Man, what the heck, man? What the heck? All right, let's try that again. Vertex, 0, -6. X-intercept is -3 and 3. When is it across the y-axis? All the way down here, right? Crosses at -6. Now, if you're wondering, oh, but I put mine in a coordinate point, that's fine. You know, because all I'm saying is what the x-intercepts are. If it crosses at -3 and 3, you could have made this -3, 0, 3, 0, and made that 0, -6. That's fine. Give the intervals in which the function is increasing. Well, it's increasing from 0 because you go from left to right. It starts at 0 and it goes up, 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 up. So we're only looking at the x-axis again, right? So it starts from 0, and as the x increases this way, it's going to keep going to the right. So we're going to say starting from 0 to infinity. Notice that they're both parentheses. They have to be both parentheses because you can't include 0, and 0 means it's just staying still. It's not going up or down. and infinity can't be included because you can't ever reach infinity, all right? And then going from that's decreasing, well, start from way up here. And if I'm way up here, that means I'm way over here on the left on the x-axis. That's why we start at negative infinity. And we go all the way down to 0. Okay? There we go. Now let's state now whether we have an even, an odd, or a neither function here. If you look at it graphically, even though, okay, like it says algebraically, we'll get to algebraically, but if you can draw a line down the middle, and when I mean down the middle, I mean down only the y-axis, if it cuts your graph in half, then we automatically know that's going to be an even function. Okay, so that's how you do it graphically. Okay, I want you to do it algebraically, but just for the record, if you just draw a line down the middle of the y-axis, if you have the same image on the left and on the right, that's called an even function. But how do we test that algebraically? I did not give you full credit if you didn't do it algebraically. This is how you do it algebraically. Here's the test. Right? This is how you test it. That means if I take my function and if I plug in negative x, if the original function pops out, the original function, such as up here, then this is called an even function. Okay? So let's do it. Let's plug in negative x. So, oops, I just got rid of the thing there. So I'm going to replace right here with negative. So I'm going to say f of negative x equals 2 times the absolute value of negative x minus 6. Notice I just replaced my x value up here with negative x. Well, let's check this out right here. Absolute value of a negative number is always going to be positive. So that's 2 times absolute value of positive x minus 6. Oh, look. This right here is the exact same thing as this. So by definition, I plugged in a negative and out came the original function. So see, look, this is equal to that, which is equal to this, which is equal to that. So negative fx equals f of x, which that's why it's even. So this is the work I wanted to see to get the full credit. If you just put that it was even, that's nice. You only get half credit there, but that's how you show it algebraically. Continuing along. What is the value of f of 9? Meaning replace the value of x with 9. So that's 2 times the absolute value of 9 minus 6. Well, what's the absolute value of 9? Well, that's 9, right? So now that's 9 times 2 minus 6, which is 18 minus 6. And that gives us 12. Voila. Going on down here to number 3. 2 coordinates are given. Hala. Hulu. 2 problems, or 2 coordinates. First, we have to find the slope-intercept from the equation of the line that passes through the 2 points. And then, can you tell me what the slope is and the y-intercept? So if I'm going to find the equation of a line, I know I have to have y equals mx plus b. I need to find an m, and I have to find a y-intercept. So first, let's focus on the m. The way we find m is we use our slope formula. y2 minus y1 all over x2 minus x1. So look right here, x1, y1, x2, and y2. Okay? So let's do it. y2 minus y1. So 5 minus a negative 1. Negative 5 minus 5. Negative 5 minus 5 equals 6 over negative 10. Well, I can reduce this, right? I mean, look, 2 goes into both of them. So 2 goes into 6 3 times. 2 goes into negative 10, negative 5 times. So this is my m, or known as my slope. So I can automatically just put this right here. Negative 3/5. And notice I just put the negative here in the middle. Doesn't matter where you put it at. We get the equivalent value. But how do we find the y-intercept? Well, really what we can do right now, I'm just going to kind of move this. Oops. Oh, wait. Sorry. Bing. Let me see, will I be able to... I was going to try to click on all that, but I guess that won't work. It's all good. So what I want to do is this right now is I'm just going to erase this right now because I'm kind of running out of room and all that kind of stuff. I'm just going to kind of erase this. I know my slope I know my slope right here is negative 3/5. So watch this. When I use the point slope formula, oops, when I use the point slope formula, I'm going to be able to derive my equation. Meaning, if I know that my slope is negative 3/5, then watch this. I can plug this in for m, and I can plug in that y1 and x1. See over here, I have my x1 and y1 over here. So let's just use my first points. Okay, we'll just use the first point to do that right there. So y minus y1, and we'll just say this is my y1 right here, which is a negative 1, equals my slope, which is negative 3/5 times x minus 5. I'm using this as my x1 and my y1. I could have used this point as well. So this is going to give me y minus a negative 1, so that's going to give us a plus y plus 2. So negative 3/5 times x is a negative 3/5 x. Negative 3/5 times 5, well, like the 5's on top and the 5's on the bottom, so those kind of just cross out, and so we just get plus 3. And if you kind of see this up here, negative 3/5 times negative 5. Does this kind of make sense right here? That you can just kind of do this kind of thing and say, oh, look, that 5 crosses out with that 5. And I have, so 5 divided by 5 is just 1, so negative 3 times negative 1 is just our 3. So that's kind of where that guy comes from right there. So subtract 2, so we get negative 3/5 x plus 1. And, oh, you know what? Actually, y minus a negative 1 is going to be a plus 1. Sorry about that. Let me just fix that real quick there. It's going to give you a plus 1. All right. So plus 1. So that means if I subtract 1 right there, that's going to give me a 2. Which means that my y-intercept then is 2, because this is mx plus b, where my b right here is always my y-intercept. All right, and there goes problem 2 then.